We're going to discuss the next method for solving the system of linear equation. We are going to find inverse. We have different methods for finding inverse, and the first method we have just discussed last time, where we're having 2 by 2 matrix, where matrix A and matrix A was 2 by 2, we're having A, B, C, D, and we developed a formula for finding inverse of this one. We said this A inverse is equal to 1 over AD minus BC, and then we interchange D and A and multiply B and C with minus sign. So this is the inverse. This is just a formula. We'll explain you further. Now the method we are going to discuss today is the elementary matrix method. We know already that we can have the identity matrix, and for inverse we must have a matrix which is square matrix. Example, I'll take here identity matrix 3 by 3, I3. So then we having discussed earlier row operation or elementary row operations. There were 3 row operations. Number 1, we can interchange 2 rows. Then number 2 was we can multiply a row with a non-zero real number, and number 3, we can add multiple of one row to another. Add multiple of one row to another. And we discussed methods for using this one to find the solution of system of linear equation. There was Gauss elimination method, Gauss-Jordan method. Then we just revised this one, row echelon form, reduced row echelon form. So we discussed the method for solving system. So here, if I have the identity matrix and I make only one row operation on this identity matrix, this becomes elementary matrix. For example, I take here E1 as elementary matrix. What I do, I interchange 2 rows. I interchange row 1 and row 2. This I interchange. So this matrix, I say here, I interchange R1 and R2. This is my elementary matrix. I can have thousands of element matrix. I make E2 is my, I take the identity matrix and make the row operation, multiply any row, a row with a non-zero number. For example, I take identity matrix and multiply the first row by 5. 5 R1, so I get here 5, 0, 0, 0, 1, 0, 0, 0, 1. I take here number 3 and I take the row operation here, and the third row operation. I multiply row 1 by 2 and add row 3, my identity matrix. So I'll get here 1, 0, 0, 0, 1, 0. I get here 2, 0, 1. If I multiply any matrix with this row operation, any one of the row operation, then the same row operation is transferred to that matrix. So if we multiply 2, then the 2 row operation will be transferred to that one. If we multiply 3, third row operation will be transferred to that one. So that's the basic idea of the identity matrix. Now here, how we apply the identity matrix to find the inverse of a matrix, that is very interesting, that we take the matrix A, any matrix, obviously as I said, then we want to find the inverse, must be a square matrix. I'm going to take here a matrix A, then I take identity matrix of the same size, I make a row operations, and if I am able to change this A into identity matrix, if, then my I is changed to A inverse. Very interesting. That's the formula. That if we make the row operation, here we make the row operations, through row operations, if we are able to change this matrix A to identity matrix, then I will change to A inverse. That's the main idea behind that one, finding A inverse of that one. I take an example, small example, and show you with the help of that example. I have a matrix A. My matrix A is 2, 3, 4, and say 2. I take A inverse. I take here 1. So my A inverse is equal to 8 minus 3. Sorry, here 8 minus 3. Interchange these two, 4 and 2, multiply by minus 3 and minus 1. So the result is here 1 over 5, 4 minus 3 minus 1 and 2. The usual method, which I give you the formula for that one, we apply that one. Now I take here the second method. The second method is that I take A and I take I. So here I'll get my A is 2, 3, 1 and 4, and my I is 1, 0, 0 and 1. Now I make the row operations. I want to bring above 1, so interchange row 1 and row 2. I get here 1, 4, 0, 1. I say I interchange R1 as a row operation. I'm allowed to do that one. So I get here 2, 3, 1, 0. Now what I want to do, I want to make this value equal to 0. To make this value 2 equal to 0, I multiply this one by minus 2, the row 1, and add to my row 2. So I just in this one and come back to that one. Here I say here I multiply my row 1 by minus 2 R1 plus R2. This is my R1, 1, 4, 0 and 1. Multiply minus 2, get here 0. Multiply minus 2, we get here 5. Multiply minus 2, they remain 1. Multiply minus 2, we get here minus 2. So that's the thing we get. Now I want to make this one 1. To make this one 1, I take 5 out, and I can rewrite this one. I divide by minus 5. I have here minus 1 by 5 R2. So get here 1, 4, we get here 0, 1. We get here 0, 1, minus 1 by 5, and 2 by 5. I want to make this one 0. I multiply by 4 and add to that one. Minus 4 R2 plus R1. So I get here 1, get here 0. Multiply minus 4, I get here 4 over 5. Multiply minus 4, I get minus 8 over 5. Then we're having plus 1 is 5 by 5. So get minus 3 over 5. Then I get minus 1 by 5, 2 by 5, and here I get 0 and 1. What I'll get? I get this one as I. So this will be my A inverse. So it's my A inverse. My A inverse is 4 over 5 minus 3 over 5 minus 1 over 5 and 2 over 5. I take 1 by 5 common. I take it out. I get here 1 by 5 out. I get here 4 minus 3 minus 1 and 2. You can see it. We have the same result. But here we have introduced the new method for solving this one with the help of doing that. We start from the value A and I, and we end up with this one, I and A inverse. This is my inverse. That's how we can solve our problem. This was for 2 by 2. Now we extend this one and we take a matrix which is 3 by 3, and we apply the same one to solve it.